Welcome back, Year 10s, to the third video in this series on algebra skills for maths methods. Today we're going to look at simplifying, multiplying, and dividing fractions, something that you've already done. And the only thing that's going to be different today is we're going to allow pronumerals and variables to be part of our fractions. We'll see that it's actually pretty much the same, and we've just got to keep track of various factors when cancelling. So let's start with simplifying. I'm going to start with a very simple fraction, 8 on 12. And just by way of reminder, when I say simplify, my goal is to write the fraction in such a way so that the numbers are as small as possible without changing the value, and cancel any common factors. Okay, so we'll start with 8 on 12. What I'm noticing is that the number 4 is a common factor to both 8 and 12. So I can actually write this as 4 times 2 divided by 4 times 3. I haven't done anything mysterious there. And now the cancellation part. So recall from your previous studies of fractions that if I have a number multiplying the top and the bottom of a fraction, and that number is the same, which in this case is 4, I can cancel it. Old books will often do this. They will cross out the number and write the number 1, and I'm happy for you to do that as well. So 8 on 12 is the same as 2 on 3, and that should make sense to you because you've seen something like this before. We're going to do the exact same thing for the next 3 examples. The only thing that's going to change is now my factor could involve the letter x or y. So let's do the second example now. Here, I've got 12x divided by 36. My goal is to simplify. So the question I'm asking is there a common factor to the top and to the bottom? The answer is yes. There is a common factor of 12. So I can write this as 12 times x divided by 12 times 3. And again, I'm noting the common factor of 12, so I can now cancel. And this leaves me with x divided by 3. By the way, you can skip this first step and just go straight to the answer if you have a lot of experience with this. You don't have to write this step here. For longer calculations, it might be helpful too, but for a one-step calculation like this, it's probably unnecessary. All right, let's do the third example. Here, 20 doesn't actually go into 50, so I'm not going to be able to cancel 20. I am, however, going to be able to cancel 10 because 10 is a common factor to both 20 and 50. So I'm going to break 20 into 10 times 2. And because I've got 20x, I'm going to multiply by x at the end as well. On the bottom, I'm going to break 50 into 10 times 5. And I've multiplied by x and by y. Okay, so I've broken up the top and the bottom into its various factors. And now I've got to look, can I cancel anything? Well, I can cancel the 10. And can I cancel anything else? Yes, I've got an x in common to both the top and the bottom. So that leaves me with 2 on top divided by 5 times y. And we just write that as 5y. I hope you'll agree that 2 divided by 5y is a lot simpler to deal with than 20x divided by 50xy. And that's the goal of simplification. We want to make life as simple as possible. So make numbers smaller and get rid of any unnecessary letters. Okay, last one. It looks like a beast, but it's actually pretty simple. So here we go. I haven't actually done anything on top, but on the bottom, I'm going to break 25 into 5 times 5. And remember, when I write brackets, that means multiplication is happening. Okay, so on top, I'm multiplying by x plus 1 and x minus 1. On the bottom, I'm multiplying by x minus 1 and x plus 2. And now I'm ready to look for some cancellations. I've got a 5 on top and a 5 on the bottom, so I can cancel those. And on the bottom, I can't cancel the x plus 1. I can't cancel the x plus 2. But I do have the number x minus 1 in brackets on both the top and the bottom, so I can cancel that. This is going to leave me with 1 times x plus 1 on top, and 5 times x plus 2 on the bottom. And an accepted convention is if we write a number to the left of the bracket without multiplication, we've actually implied multiplication here. So there's actually a hidden times symbol here, but we don't actually need to write it because we understand that when I write a number on the left like that, we'll just multiply. So I'm happy for you to leave your answer like this. You don't need to expand the brackets, and you don't need to explicitly write 5 times x plus 2. For short questions like this, you can just go straight to the answer. That's fine with me. The reason why I've written the first step is to show you where the cancellations are happening, and I hope that makes it clearer for you. Okay, let's do a few more examples with multiplication and division. So here we go. I'm going to do it 2 ways. So first I'm going to do it the long way to make it clear, and then I'll do it the short way, which is what most people will do in practice when solving these kinds of questions. The key idea here is when multiplying fractions, we can cancel common factors across different fractions. So before, we only worked with one fraction at a time. But when multiplying fractions, I can actually cancel across. As long as I've got one factor on top and one on the bottom, even if they belong to different fractions, I can still cancel them. So let me demonstrate what's happening here. So let's start with the one on the left here. So what I'm noticing is that the number 24 is the same as 24 times 1. And the number 48 is the same as 24 times 2. If you don't see that, break it up into 12 times 2 and 12 times 4 instead. And then due to cancellations, it'll just take an extra step, and that's fine. For the number 35, what I'm noticing is that that is the same as 7 times 5. And the number 49 is the same as 7 times 7. And now let's look for some cancellations, remembering I can cancel the top and the bottom across different fractions. So the 24, that's going to cancel. And the 7 here, we can cancel. One thing I need to say before I continue is we can only do this cancellation when multiplying. We can't do it when dividing, but there is a simple workaround that, which I'll show you in a moment. Okay, so now I have a situation where I've only got 1 times 1 times 1 times 7 on top. And on the bottom, I've got 1 times 5 times 1 times 2, which gives me 10. Do you see how easy that was? I didn't need to do 24 times 49 and then 35 times 48, get these massive numbers and then try to cancel them, because that would have been a nightmare. If you see a common factor, you want to cancel it before you attempt to multiply fractions. All right, so this is the long way. Now for the short way. This is the way I was taught to multiply fractions like this. 24 goes into 24 once. I'll just rewrite this again. One moment. So 24 and 35, 49 and 48. All right, so 24 goes into 24 once, and 24 goes into 48 twice. I have now cancelled the factor of 24. 7 goes into 35 5 times. 7 goes into 49 7 times. I have now cancelled the common factor of 7, and now I will have 1 times 7 divided by 5 times 2, which gives me 7 on 10. I'm very happy for you to just write this. The top is clearer, but it takes a lot longer, and it becomes impractical for very large calculations. Okay, let's carry over this idea to an algebraic fraction. So now I'm allowing the fractions to involve pronumerals and variables. So first I'll do it the long way. So I'm looking for common factors. Well, I'm seeing 5 and 15. That's probably going to cancel. And the x plus 1s are going to cancel as well. So I'm just going to break up 5, x plus 1 into its factors. 5 is prime, so I can't break it down any further. But 15 I can break into 5 times 3. Now, 8x, I'm going to break that into 8 times x. And I'm noticing that 16 goes into 8. So I'm going to cancel the 8 somewhere. So 16 becomes 8 times 2. And x squared, that's going to cancel the x. X squared is the same as x times x. There are two x's because it's x to the power of 2. And now we can use the cancellation rule. So let's look for some common factors. The 5 and the 5 here, those are going to cancel. The 8 and the 8, that's going to cancel. The x plus 1 and the x plus 1 is going to cancel. And one of the x terms is going to cancel. So what I'm left with is 1 times 1 times 1 times 2 times 1 times x, which gives me 2x on top. And on the bottom, I have 1 times 1 times 1 times 3 times 1. So that gives me 2x divided by 3. Again, I hope you're seeing that 2x on 3 is much simpler than this mess on top. And that's why we are teaching you to simplify fractions. If we can make life easier in maths, we want to do it. All right, now I'll just show it to you the fast way. So I'll write the question again. Okay, so the x plus 1 and the x plus 1 will cancel, giving me 1 and 1. The 5 and the 15 will cancel to 1 and 3. The 8 and the 16 will cancel to 1 and 2. The x and the x squared will cancel to 1 and x. Because x squared has 2 x terms, so I can only get rid of one of them. Some people would just cross out the 2. I prefer to cross out the whole thing just to make it clear. And now if we do the multiplication, again, we get 2x on 3. So if you're comfortable doing the quick way on the bottom, go for it. If you're still developing your confidence for fractions, I recommend writing out the long way for the first few and then gradually move to the bottom once you're more fluent with it. Okay, to divide by a fraction, let's say I'm completely general. I have two fractions, a on b, and I want to divide by c on d. We define a on b divided by c on d to be the same as a on b times d on c. So wherever you see division, what you want to do is replace the division with multiplication, keep the first fraction the same, and replace the second fraction with what's called the reciprocal of the original fraction. So here I've turned c on d and flipped it upside down. As long as you remember that, division is easy because it's just multiplication in disguise. All right, so I'm not going to labor the point. I'll do these two examples quickly and then let you have a go at some questions. So here, in the first example, I'm going to change this to 33 and 45 times the second fraction flipped upside down. So now I will have 81 divided by 77 as the second fraction. And I'm just going to do the quicker way. So 11 goes into 33 three times, and 11 goes into 77 seven times. So I've cancelled the common factor of 7. On the bottom, I'm seeing a common factor of 9. 9 goes into 45 5 times, and 9 goes into 81 9 times. So now I have 3 times 9 on top, which gives me 27, and 5 times 7, which gives me 35. And I can't cancel this fraction any further because 27 is a power of 3 and 35 is a product of 2 primes, 5 and 7. So we're finished. Now for the second one. I very strongly recommend that you don't try to do this in your head. Just change it to multiplication and then deploy your simplification skills. Okay, so all I've done is I've flipped the second fraction upside down and changed the division sign into a multiplication sign. I know from experience that some of you will feel uncomfortable with this. Like, why are we allowed to do this? Please feel free to chat with me about why we are allowed to do this. It's subtle. Usually at school, we just teach it as a rule, and you practice it so many times, it becomes second nature, like your times tables. But if you're interested in why this is the case, feel free to just chat with me and we can talk about it, and it's worth doing so. Okay, 5 and 10, that's going to cancel to 1 and 2 because it's a common factor of 5. 3 and 6, that's going to cancel to 1 and 2 because it's a common factor of 3. And the x minus 3 is also going to cancel as well. So at the end, I'm going to have, well, actually, there is one more cancellation that's going to happen because I've got 2 and 2. So I can actually cancel that to 1 and 1. And this can sometimes happen in longer calculations. You cancel, and then you can cancel again. And that's totally fine. Don't worry about trying to get all the cancellations in one line. Sometimes that's impossible. And as you can see in this case, it wasn't immediately obvious. So you'll see that we just have x plus 2 on top and x plus 1 on the bottom. Okay, so that's it. The main idea in this video is if you are multiplying two fractions, all you need to do is look for common factors and cancel them. Perhaps what was new today was cancelling across different fractions that are being multiplied. And hopefully, when dividing fractions, it's something that you've seen before. Maybe you've just forgotten it because you haven't done it for a while. So I will upload these notes to Teams, but this is just a very, very brief summary of what I've talked about today. Multiplying fractions is easy. In the next video, we're going to add fractions, and that's going to take a bit more work. So I will see you at that time. Thanks.